Reaction kinetics is the study of the speed at which reactions happen. Let's start with two gentlemen a long time ago, an influential man with a candle and a rich man with a bag of gold. And they have agreed to have a meeting. The man with the gold has bought the time for the meeting, and the man with the candle has determined that the length of the meeting will be as long as the candle can burn for. When the candle's burned out, the meeting is done. Here we get a sense of rate, and the rate is related to the length of the candle, and we begin at a certain time, and when that candle's done, the meeting is over. And in this very short example, we have everything we need to define how to find the rate of a reaction. Something that is measurable, something that changes in relation to the rate of a reaction, such as the speed of the candle burning. And that is compared to a time, always to time. In this imprecise example, a meeting, one meeting. A more precise example would use a standard unit of time, which in the metric system is the second, but we also will use minutes for slower reactions, even years, even billions of years in the case of an extremely slow reaction that produces diamonds. The conversion of coal to diamond literally takes billions of years in the ground. Nonetheless, we can calculate rate. Well, let's look at a definition of rate then. Rate of a reaction is delta amount, the change in the amount. Change is difference or subtraction compared to delta t, the change in the time. A later time minus an earlier time, perhaps. So using this, let's do a specific example. How about a chemical reaction that should be familiar? If we drop into a beaker some hydrochloric acid, well, let's just place it there actually, but let's plunk in some zinc metal. Almost immediately a reaction will begin between the two. The zinc, which is solid, which will react with the hydrochloric acid, which is aqueous, to produce zinc chloride, which we won't even see it because it's dissolved. But the hydrogen gas that is produced will appear as bubbles, and they will escape the system. There's our way to measure the reaction rate, because the whole system will get lighter. So if we measure the mass of the system as the hydrogen escapes, we can make a table of values from which we can track the reaction going on, and then from that, calculate the rate. So let's say, at time 0, there's 100 grams. That's the whole setup, everything included. But after a while, 30 seconds, it's dropped to a mere 90 grams. After another 30 seconds, it's 84 grams. You might see that it's actually slowing down. And then at 90 seconds from the beginning, there's 82 grams of mass in the scale. Now understand that the mass change is showing the production of hydrogen gas. And since it's leaving, the mass of the system is getting less. But this mass change is hydrogen. It's in an open system, which it has to be for the gas to be able to escape. Well, here's the problem. Maybe you can pause and try to calculate it without seeing the answer. Calculate the rate of reaction in grams per second. But wait, we need to know over the time interval. So let's say between 30 seconds and 90 seconds. Go. All right, well, let's have a look at this. The rate of hydrogen production is the change in the amount. So, well, let's go down to the beginning. We were asked to look at 30 seconds, and at that point there's 90 grams in the system. At 90 seconds, there's 82 grams. This difference will show us the change in the amount of hydrogen. We need to put in the time difference as well. We start at 30 seconds and end at 90. Following the way we calculate slope, this is like the change in the rise over the change in the run. Now in this case, because the mass is decreasing, it's going to show a negative value. But that's okay. We'll just calculate it. This is 8 grams in 60 seconds. And again, that negative just means that the mass is leaving. But we know that the hydrogen amount is increasing. So we do the calculation. It's 0.133 grams of hydrogen per second. So therefore, hydrogen is being produced at 0.133 grams per second. And that is it, the calculation of the rate of the reaction.